first sight. WeBWorK is all about assignments, but an assignment in WeBWorK is a collection of problems, of questions, or exercises, whatever you want to call them. Let's create one of such questions, and then let's create an assignment, and finally put the question into the assignment, and as a last step, let's deploy the assignment onto the student's class. A question in WeBWorK has a certain anatomy. In WeBWorK, a question has a description, may have a figure, it has one or more randomized parameters, one or more answer formulas written as functions of the randomized parameters, and one or more entry boxes for students to submit their answers. We shall see what I mean by all of these. That is what the student will see. That is a question. Assignment 1, problem 4. In it, we identify what is the description of the problem, what is the figure, and look it up here, a randomized parameter. We read the feedback resistor Rx is 12.5 kiloohms. Well, each student in the class will get a different value for Rx. That is a randomized parameter. But the students asked to respond for certain values, and here we have entry boxes to collect the data from the student. Those are the 4 parts of a question: description, figure, randomized parameters, and entry boxes. When the student enters an answer, the box turns green if the answer is correct, or red if the answer is wrong. So the student gets instantaneous feedback. How many attempts? As many as you, the instructor, decides. 1, 2, 3, 10, 20, 100, an unlimited number of attempts. It's up to you. In the code, we see the description. In WeBWorK, a question is a text file, so you can use Notepad or any other text editor to create your question. A text file that has the extension .pl or sometimes .pg. I prefer .pl because my editor identifies .pl files as a Perl source code and highlights the keywords correspondingly. There's a description. It is just text. In the circuit shown, the feedback resistor Rx is. What is with that pair of square brackets there? Those square brackets read the value of what? The value of that variable. What variable? $Rx. You see, in Perl, which is the underlying language of WeBWorK, a variable name begins with a $sign. So there you go. The feedback resistor Rx is the value of the variable Rx divided by 1,000 kiloohms, etc. We need to define that variable, right? The variable is defined in code like this one. The variable Rx is a real number created by the randomization function with a value between 2,000 and 15,000 in steps of 500. So 2,000, 2,500, 3,000, 3,500, all of those are legal values. Compute and report the output voltage of the amplifier. So we need to create a box for the student to enter the answer, and that is more text down here. Enter your answer for V0, and we create that box. You see the box there? Square brackets and underscores. How many underscores? As many characters width you want in the entry box. It's up to you. The student enters the answer there, and WeBWorK will compare whatever value the student puts there with the contents of the variable $V0. So we have to write, for the sake of WeBWorK, how to compute the value of V0 as a function of the randomized variable Rx. That is how the answer is computed, and WeBWorK will compare the student's answer with that one and credit some marks or not. What about the figure? The figure, I recommend that you set up in the format PNG, Portable Network Graphics. It takes other formats as well, but I found that PNG works the best. How to include that in the text file that is the description of our question? one line, this one, bracket ampersand, and close here with ampersand bracket asterisk. And inside you have a call to the predefined function image that has three parameters: the name of the figure file, the PNG file, the width in pixels, and the height of the figure in pixels. Not the actual width and the actual height, but rather the wished width and height with which you want WeBWorK to display that question on the student's screen. So be mindful of the actual dimensions of your figure so that your figure looks proportionally represented. In the code, for real, this is what we see. What line is that? Context complex. In WeBWorK, we have to tell what kind of context we have so it activates certain functions or others. If we're going to be using real numbers exclusively, I recommend the context numeric, because in electrical engineering, most of the values are complex numbers. I use context complex. What about this line? Tolerance 0.02. I'm instructing WeBWorK to use a tolerance of 2% to deem the answer of a student as correct. If the answer of the student is within 2% of the value calculated for $V0, the student will get credit for the question. The actual visible part of the question begins with the line begin PGML and ends with NPGML. Inside we have the description, the randomized use of the variable, the image, and the entry boxes. That is the visible part. By the way, there is an error in this description. This error would drive nuts the WeBWorK interpreter. Can you see what it is? You found it, right? There. Within the brackets, the variable $Rx has not been identified with $Rx. That would give a horrible error message to the user. Sure, there are other contexts. Numeric for real numbers, complex, the ones I prefer, points, vectors, and many others. On the tolerance matter, if the tolerance set to 0.022% and the correct answer is, let's say, 1,000, any value between 980 and 1,020 will be graded as correct. But if the right answer was 0, then WeBWorK runs for the mountains. I prefer to use a tolerance of 0.002 at least. In your case, do experiment. The actual code for a question. Let's have a look at that. It has a header. In the header, there is general information for future reference, your name, your email address, when you solve that, what kind of a problem it has. It is about what? Electrical engineering, what chapter, what course. All of those things, they go in that header. It also includes some macros, right? Which is fixed code for us. That is a set of macros predefined by the creators of WeBWorK, and we only benefit from them. That code is fixed to us at first. We don't touch that header. It may also have a tail, which is also fixed code to us at first. You all will get a template for an empty question that has the header, the macros, and the tail. During the hands-on session of this workshop, please fill in the random variable definition, the answer formula, the description of the problem, include an image, and set up some student entry box or boxes. Now the real McCoy. Check it out. That is the actual file within my text editor. At the very top, we see the header. In the header, you see a lot of items that you may or may not want to include, including keywords for search if you ever release your question into the world of WeBWorK. Those are the predefined macros. I won't touch that. So the header and the macros I leave as they are. And I scroll further down where the action really happens. Here is where the action really happens. You see the random variable, where it is used, the answer variable, and where it appears here in the comparison. And further down, there is a tail. This tail is optional. I set it up because I prefer the student to enter floating point values for an answer. So I don't want expressions. I don't want 3/4 for an answer. I want 0.75. Now, I have created that question file. A question file is a Perl source code. It is a text file that has the extension PL or PG, right? For example, q1.pl or q2.pl, etc. Those are question description files. You can use any text editor to create your question file. Notepad or Notepad++. I use a GVim. It's free, it's universal. You can find a version of that downloadable for free for any operating system. Once you have written that text file, that .pl file, you upload it to the UBC WeBWorK server. What? Where? How? Okay, let me see. Where are you going to put that file question? In the server of WeBWorK at UBC. You go there and you are given a directory for your course. I recommend that in that directory, you create a folder with the name local, that is common practice in applied science. And inside that folder, you create a subfolder for each one of your assignments, ASN 1, assignment 2, 3, 4, 5, 6, 10, etc. The name of the folder, the name of the assignment. I suggest that you use short names. Why? Because at the end of the term, when you get a report for the entire course, at the top of the column for each assignment, you will see that label. At first, I was using names for assignments like magnetic circuit, three-phase induction motors, and so on. So imagine how wild the titles of those columns became. So now I use ASN1, ASN2, sometimes PS1 problem set, PS2, PS3. So QS1 question set 1, question set 2, whatever works for you. But I suggest you use short names. Short names there. Inside each one of those folders is where you're going to put your PL files, the question files, and also the figure files, the PNG files. Q1 PL, that is the question, and Q1 PNG would be the figure for question 1. Visually, the deployment of files works like this. In the WeBWorK server, you're given a directory. Inside of that, you create a local subdirectory. And inside that local subdirectory, you create different folders for different assignments. Inside a folder for a given assignment, you put the PL files, the description files, the text files in Perl, and the figures PNG. Look, I log into WeBWorK and UBC, select my course, which in this case is Upside Workshop, whatever course you are using, and you click in using your campus-wide login authentication, and this is what you see. You see what assignments are available in that pseudo course. In this case, only assignment 1 has been created, it is open, and it's due at this day, at this time. But we're going to create a new question, right? We have done that in our hard drive, in our local hard drive, in our laptop, and then we click on File Manager. That's how we gain access to the server of WeBWorK at UBC. Click on that, and we see there the subdirectory that WeBWorK at UBC has assigned to our course. In it, we are going to go to New Folder and create a local subdirectory. Inside that directory, again with New Folder, we create a folder ASN 1, 2, 3, 4, etc. for each one of the assignments. Inside one of them, we enter Q1 PL, Q1 PNG, the question description in Perl, and the figure in portable network graphics format, and the same for question 2. Some questions don't have a figure. Some questions use all of them the same figure. All of that's possible. Some questions may have more than one figure. How do you put those files there? In that directory of local inside the web server of UBC. This way you click on choose a file. It opens a dialog box that allows you to explore the hard drive of your laptop. That's how you select a file, and then you click upload and the file ends up here. When files are there, you have all of those functions available. You can view a file, you can edit a file right there, download it back to your hard drive, rename it, copy, delete it, or get several of those files and create an archive of file. Now, let's create an assignment. Now that the question and the figure files, PL files, and PNG files are on the server, we need to define an assignment as a collection of all of those or some of the questions that we've already put in the server. In that definition, we will decide when the assignment will open for the students, what students will see it, when is the deadline, when, if you allow it, final answers will be visible to students, how many marks to grant for each question, how many attempts you will allow students to answer correctly each one of the questions. For that, we trigger the homework set tools editor, right? Where? Here. You have the instructor tools, the homework sets editor. You click on it, and in it what we want to do is to create a new homework. So you click on that tab, create, and it allows you to give it a name to the new setup here. Give it a name. ASN2 is going to be our second assignment. What kind of assignment set is that? You could set it up as a copy of an existing one. In this case, I chose the option a new empty set. Take action. There you go. You see, here you have that assignment 2 has 0 problems. We have not assigned any problem. We have not attached any question to assignment 2, while assignment 1 already has 5 questions. One thing they have in common is that it's been assigned to only one of the 12 people in the course. Guess to whom? Yes, to yours truly, to the creator of the problem. Later on, we will assign that assignment to all the class. We click on the little pencil there, and that allows us to set up when it opens, date and time, and when it closes, date and time as well. And if you will allow the answers to become available at some point, well, that's where you say when. Visible to students. Well, I am developing an assignment. Normally, I say this to no. I don't want students to get distracted or confused by a set of problems that is under construction. There is something else. Check it out. When the student hovers with the mouse above the names of the assignments, that little balloon appears that tells him or her a little description of the assignment. Thevenin Norton maximum power, RC circuits, op-amps, diode circuits, MOSFETs, bipolar transistors, and so on. Where do you instruct WeBWorK what kind of a post or balloon you're going to include there? Here, you see this set description. Whatever you write there will appear in the pop-up when the student hovers over the name of the assignment. Let's go back here. The set does not contain any problem yet. We knew that. So what we do is we say add 5 blank problems at the end of the homework set, click select, and save changes. And this is what happens. We scroll further down and we see that 5 blank templates have been added. In it, we can change the weight of each one of the questions. This question 1, we want it to be 20 marks. We can change how many attempts we'll have the student try until he or she gets a right answer. 7 in this case. You could say that for unlimited. and very importantly, where the source file of the question is local directory asn2 file q1.pl. We do that for each one of the other questions. Right now they have placeholders, and at the end we save changes and the assignment is already stored. Check it out. Yeah, we go to the homework sense editor, scroll down, and we see that assignment 2 now has 5 questions, but still it's been assigned only to one of the 12 people in the class, to me. Click on that and it will give you a list of all the students in the class with a check mark here and near the names of students for which the assignment has been deployed. Assigned to all current users, save, and now the assignment has been deployed to all the class. And that's how assignment 2 will open on this date at this time. And with that, my friends, there is only one thing to say.